Okay, so this is how the initial diagram I made. It's very complicated for the intake system of where we can put arms with wheels on the end to make sure and grab and stabilize the toes. This was too complicated to do by hand, so I went and did an Autodesk Inventor, and here's the result. Now this also looks complicated, but actually I have everything down to 3 variables. Only 3. The rest are givens. This 12 inches, this 8 inches of clearance, and this 10 inches, which is the distance between the pivot where the arm's going to be and where our things are going to be attached. So, by changing these 3 variables, we can figure out what it's going to look like when the arms are in and what it's going to look like when the arms are out. Right now, if we put the actuator 12 inches from the side, give it 8 inches of clearance with which through which it can extend, and put our devices exactly 10 inches from the pivot, it will begin at our 19 inches, which is our target mark, and extend outward to give us 29 inches of range. Now we can change these variables. Hang on, watch. I can change this because we may not have 12 inches there. We have to look at the design of the robot. We may only have, let's say, 8. And that changes it. It skews this, but it also gives us greater range. Now, it doesn't, according to our design, this skew won't really matter very much. The fact that we have range does. We also may not have these 10 inches, so we can change that maybe only to 5, maybe 6. Let's go to 6. See what that looks like. That gives us a huge amount of range. But this, and with still 8 inches of clearance, but that might be too much range. So let's give it a little less clearance. Let's give it only 4 inches of clearance. There we go. Now it extends from 19 to 24. I actually like that one right there, because that one I think will work best with our robot design. But this is the best example I can give of how to use Autodesk Inventor to help with your mathematics and basic concept design of the robot.